Okay guys, welcome back to the snake game, and this is already part 4. And so what do we have here? So far we have a fully functioning snake game with the possibility of collecting those chickens and with the possibility of ending our game. And so now let's try to develop some measurements. So we would like to measure the score of the game, so calculate the score of the game, and let's say we want to count with how many moves have we collected all those chickens, right? So the less the count of moves, the better, of course. So it means we have gone more efficiently. So let's say we want to correct this HTML now and to add some information about the score. So go button is there. So let's say this will be in another div, and we will introduce there, let's say, a label where we will depict the information about the score. So let's say it will say moves, and another label where actual moves will be printed out. So let's say 0 at the beginning. So this will be corrected by JavaScript. So let's give some ID to it, moves, and let's just make it a bit bigger. So font, I don't know how it was, font size, could be font size 24 maybe. Let's see how it looks like. No, style equals, okay, of course. Style equals, so yeah, this is larger. Let's just say we want it to be a bit different color, so I don't know, green, let's say, and that's it. Okay, so there will be our score. So now where do we calculate our score? We calculate when we redraw the thing. It means then another move is happening here. So and afterwards we can take in jQuery our moves, and we say inner text plus plus, just like so, right? No, not like that. Moves, it was moves, yes. Inner text. Oh, it is an array, so 0. Yeah, that's right. So we can see that our moves is counting, and that's cool. Actually, at the very end we want to print out the result. So the end is here. You won. Let's say you won in so many moves. So this is the same thing here. Okay, so now let's say if it works, and then so what we actually want to do is to make it not an absolute number, of course, but relative to the size of the grid, because of course it's more difficult to get yeah, you want into 65 moves. It's more difficult, of course, to get low number in big size. So what happens when we resize this thing? We can see that everything is redrawn when we make a resizement, and of course also those obstacles, 30 obstacles in smaller grid is much more dense than in larger grid. So let's just say that we actually generate the count of obstacles depending on the size of our grid. So here obstacle count is 30, but actually we will calculate when we start everything. Where is that? Ready. Here in this function on resize we call generate stuff, and in this generate stuff function we will start by, after initializing grid, we will start by assigning a random, no, not a random, but let's just say we calculate this thing based on the size of the grid. So so we have x count and y count. Let's just say x count times y count. So this is about, so these are all our cells, and let's say we divide it, I don't know, by 100. Let's see how it looks like. Okay, it's more than before, but it looks quite alright, I think. No? And now what happens when we resize? So we make the grid smaller and everything gets less. That's cool. Not everything, but those obstacles, of course, yeah. And also we can play it here in this smaller grid. So now it's relative, the obstacle count is relative, but now we want to also correct this score thing. So okay, these are absolute moves, but let's say we don't calculate moves, but this will be a score, not moves. One thing is moves, but another thing is score, and let's just maybe really call it score, and then so new head position. So here is a score and here is score, but now let's just say that it's not just plus plus, but we divide it by the cell count, the total cell count in our grid or something like that, to get the actual number. So we will actually really use some other variable moves that will be increased by 1 here, but here we will say that this inner text is equal to moves, let's say, divided by the size of our grid, x count times y count, and then let's say mass floor of that, and then not u1 in moves, but u1, your score is no, this is the right thing, so many, let's say, magical points. And now this variable moves must be initialized somewhere, so we will have this variable declared here, and we will initialize it when the document is ready, generate stuff. Let's say here moves are 0. And now, so nothing changes. So why is it so? Document ready moves are 0. So what happens now when we redraw moves plus plus? Okay, mass floor it's equal to 0, because it's not doesn't get very large because it's equal to 0. So let's multiply it by something that guarantees us to get our 1 at least. Let's say, so if our grid is about, I don't know, 80 times 50, it means 4,000, right? So if we multiply it by 10,000, then we get something here. Okay, cool. So now it doesn't count actual moves, although it looks very similar to that, and it's good actually that it looks like that, but it's calculating some very strange relative thing. And let's okay, and let's see what's happening when this grid is like that. Okay, we have to initialize it back to 0 when we resize also. So let's say let's put it initializing stuff not there but in generate stuff, because it's happening also on resize. So generate stuff, moves are 0. So let's see. So we get something there, and now we will resize, and it's happening nothing. Okay, we regenerate. We assign it to 0, but we didn't change the thing of that value. So also we have to put inner text like that. Or we can actually just of course put 0 there back as it was at the very beginning. So not all this calculation, but just 0 here. Okay, so now we have some moves and it backs to 0. Cool. So now let's see what's happening here. Okay, we can see that our moves are getting quite big already, because the grid is very small and it's much easier to get all those chickens, and so the score is much bigger. Yeah, cool. So actually maybe we have to think about how to make it more similar. But okay, maybe it doesn't need to be similar to this big screen easiness, let's say. So okay, that's it. And actually at the last lecture we didn't get rid of this draw obstacle, draw chicken, so we implemented this draw everything here, but I think we left, there is draw obstacles, this is not needed anymore, so let's just get rid of that for the purity purpose. And that's it for today, I think. So we have implemented the scoring system here, and we have implemented the recalculating of the scoring system and also of the obstacles when we resize a screen. And now let's think about levels. I think in the next lecture we will try to maybe implement something that will be different in each next level. So this would be level 1, and when we go and collect all those chickens, we have to be able to play the next level, I think. And yeah, let's think about such things for the next lecture. So that's it for today. Thank you for watching how I program here, and thank you for keeping up with me, maybe working and trying to program along with me. And so let's see you in the next lecture. Stay tuned, subscribe to my channel, and see you soon. Bye.